So here's the sheet about finding instantaneous velocity with an accelerating object. And the curved line we have here is the line of best fit or the curve of best fit for this data that's represented by these red points. And you can see that the slope is in a continual state of change. The slope starts at 0 down here, and then it gradually gets steeper and steeper and steeper and steeper and steeper. And that's telling you that it's going faster and faster and faster. And what we want to find out is, what is the instantaneous velocity at some particular moment in time? Like, for example, how fast are we going at the 2-second mark? And really what that question is asking is, what is the slope at the 2-second mark? Because the slope is the velocity. So we construct a tangent here, which is a line that just grazes our graph with the same slope as the curve at that particular point. But because it's straight, we can take the two endpoints and we can do a slope calculation on it. Well, you can see here, if we choose this endpoint and this endpoint, you don't have to use the two endpoints. You can use points in between, but the two endpoints are definitely easier. Well, right here, this would be the D2, right, because it corresponds to that. And this would be the D1 because it corresponds to this. And this would be the T1. And then straight down here, this would be the T2. So when we perform the slope formula on this blue line, we're going to have our V, because that's what the slope is D2 minus D1 all over T2 minus T1, which is, I think I'm going to run out of room here, but this is going to be 40 minus 0 all over, and your time is going to be 5 seconds minus, that's at the 1 second mark. So that will be 40 over 4, right? 40 meters over 4 seconds. So that will be 10 meters per second. So at the 2 second mark, the instantaneous velocity is 10 meters per second. At 0 seconds, the V was 0 because the slope was 0. And then as we go up and do this purple one and we do the slope formula on that purple one, now this is going to be our our D2, and this is going to be our D1, and this is going to be our T1, and this is going to be our T2. So just looking at the two endpoints on that purple tangent that grazes our curve at the 5 second mark, right? The V at 5 seconds would be 110 meters minus 0 meters. That's the D2 minus D1 all over 7 seconds minus, that looks like it's around 2.5. And so we get 110 meters over 4.5 seconds. And when you divide that, 110 divided by 4.5, and it comes out to be 24. So it's around 24 meters per second. So, and the line is steeper. The blue line has a slope of 10 meters per second. The purple line has a slope of 24 meters per second. And then the next thing to do would be to make this table of values, 0 and 0. That's how fast you're going at 0. Better save this file, save as. No. So this is going to be 10 meters. This happens every now and again. Save as. And I'll call this notes. Now it should work. So there's 10, 0, 24. And now there's our V versus T graph, 5, 10, 15, 20, 25. The times are all the same. And now we have a graph with 3 points, 0 and 0, 2 and 10, 5 and 24. And we can draw a line of best fit through these points. It doesn't have to hit all the points. And the slope of this line, the pink one, is the acceleration. So you would choose any 2 points that are on your line of best fit. You could choose this here and this one if you want to. This would be your V2. That would be your V1. This would be your T1. This would be your T2, right? So straight down, this point it's T2 and V2, and this one is T1 and V1. So if you do the slope formula on this line of best fit, you're going to get your acceleration would be 10 meters per second minus 0 meters per second, because we've chosen this point down here, all over 2 seconds minus 0 seconds, and this would be 5 meters per second squared. So that would be the acceleration, and we found it by finding instantaneous velocities from this first graph, 0 and 0, 2 seconds and 10 meters per second, 5 seconds and 24 or 25 meters per second. And then graphing them on a v versus t graph allows you to find the acceleration. And then if you want to know how fast are you going to be going after 15 seconds, well, it would just be, the v would be 15 times 5.